Hello, my name is Anna Carolina, and I'm visiting professor at physics department at St. Mary's College. One of my research and teaching interests is developing and improving new labs and lab curriculum. What makes a lab to be a good lab? Clear instructions, high chances to get nice results, supporting lecture or textbook ideas, or something else? And here we have the main question. What do we really want our students to learn in the labs? Should they learn how to follow instructions? Learn that an experiment always supports a theory? Or learn that the textbook and authority are always correct? But that's not exactly what we want our students to learn, and it's not what is required nowadays by society and job market. So I set a different set of learning goals to understand how scientific knowledge is constructed. One of the natural ways to do this and to learn physics is to follow the path of the scientists who constructed it years ago. So first make an observation, then come with some alternative explanations of these observations, then test them, and keep in mind, not verify, but really test, aiming on rejecting, and then apply the constructed knowledge to solve practical problems. In such labs, students have to design their own experiments, so these labs handouts do not contain recipe-like instructions on how to do the procedure, how to do the experiment. But instead, these lab handouts just guide students through various aspects of typical experimental process. It is much harder and sometimes frustrating, but it's also extremely exciting when it works. This fall semester, I taught a class, Revolution in Science, where students learned about developing scientific ideas about nature of light. And one of my students asked me, how come that when I learned physics in high school, all ideas we studied were correct? And in your class, most of them are wrong and being rejected. And honestly, I was very happy to hear it because that's exactly what I wanted students to learn. Scientific process is not a straightforward path. It is an erratic wandering, getting stuck in dead end, rejecting your favorite idea, coming with a new elegant idea and rejecting it again. And finally, if lucky, coming to the idea that is supported by all experiments. But still, you should be always open to a possibility that this idea can be rejected or revised. And your investigation is never over.